Everybody, this is Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Then next another slide which has the meaning of internal energy. Internal energy U, work and heat. Okay, delta U, change in internal energy is equal to Q plus W for work done on the system by the surroundings, minus W is for work done by the system on the surrounding. If it loses, then there will be minus symbol. If it gains, there will be plus symbol. So in this schematic diagram we can see that this is the system. This is the system. If work is done on the system, if it gets, means that will be plus W. If quantity of heat absorbed by the system from the surrounding, then that also will be positive in gain. If it goes out, if the system is doing work on the surrounding, then W will be of minus. If the quantity of heat energy is lost to the surrounding, or it is gained by the surroundings, means then that will be minus Q. The heat energy is lost by the system, then that will be minus Q. This is what the internal energy, work and heat are related. Okay. Then from this slide onwards we can see some problems which are related to the topics of work, heat, energy. Let us see the problem. What is the problem? A box is pulled with a force of 25 Newton to produce a displacement of 15 meter. If the angle between the force and the displacement is 30 degree, it is some mistakenly given 30 degree, find the work done by the force. The angle between the force and displacement is 30 degree. That is clearly given in the diagram. If this is the system and the force given by the man here, so that angle is 30 degree, and this is the box which with which we are going to move it for 15 meter, and force is 25 Newton. That is what is usually spent by the man. So the force is F 25N, the displacement dr is 15 meter distance. That much amount we have to move, the man has to move it. Angle between F and dr theta is 30 degree. That is degree in the last zero like or O like instrument in indication. Work done W is equal to F into dr into cos theta. This is the formula which is used to calculate the work done by the force. So the same problem given here. So these are the values, the force, displacement, angle, work done. So W is equal to force 25 into displacement dr 15 and cos theta cos 30 is root 3 by 2. So if we substitute the values 25 into 15 into root 3 by 2, we will be getting the value, and all the units other than other things, Newton meter is getting. Newton meter is equal to joules. So the work done is equal to finally 324.76 joules. So this is the answer for this problem. So the work done is 324.76 joules. So this is another problem. So a body falls freely from rest from a height of 2 meters. If acceleration due to gravity is 10 meters per second square, determine the work done by the force of gravity. Another also, this is also work done, but it is in a different form. So what are all the values given in the problem? The height is 2 meter, then the weight is weight of the mass, we are fixing that as 1 kilogram, and the acceleration is 10 meter per second square. What is asked? Work done by the force of gravity. Since it is falling from a height, it will definitely reach the earth or the lower place. So it is the work done by the force of gravity. So a W is equal to F D is equal to W into H. Work done into height. Since it is coming from height, the force is W into H. So mass into weight, that is mass into gravitational force into height. So we have to substitute the values. So 1 kilogram mass, 10 acceleration due to gravity, that is 10. What is the height? 2. So 1 into 10 into 2, that is 20 joules we are getting here. We are getting that as 20 joules. So what is W? W is the work, F is the force, D is the distance, and here in this case of W, this small w is weight, H height, M mass, G acceleration due to gravity, So these are the things what we have applied in the formula. And what is the answer? It is 20 joule. The work done by the force of gravity, it is 20 joules. So another one problem of the topic. A 500 gram cube of lead is heated from 25 degrees Celsius to 75 degrees Celsius. How much energy was required to heat the lead? The specific heat of lead is 0.129 joules per gram degree centigrade. Okay. So what are all the things given? Mass of the material is 500 grams, and the specific heat of lead is 0.129 joules per gram degree centigrade. Delta T, change in temperature, how we can get 25 degree to 75 degree Celsius. So final temperature is 75 degree Celsius. So final minus initial. So 75 degree Celsius minus 25 degree Celsius is equal to 50 degree Celsius. Using all these values in the formula. So for finding out the energy required to heat the lead is Q, quantity of heat, is equal to M into small c into delta T. M is equal to 500 grams, C is equal to 0.129 joule per gravitational force into degree Celsius into the delta T, that is 50 degree Celsius. Q is equal to 3225 joules. So what is the answer? It took 3225 joules of energy to heat the lead cube from 25 degrees Celsius to 75 degrees Celsius. So it took that much of energy. So next problem is a 25 gram metal ball is heated 200 degrees centigrade with 2330 joules of energy. What is the specific heat of the metal? So what are all the things given in the problem? So it is M, 25 gram, mass of the material 25 gram metal ball, change in temperature is equal to 200 degrees centigrade, Q is equal to 2330 joules, 2330 joules, and substituting all those values, Q is equal to MC in delta T, Q is equal to 2330 joules equal to mass 25 gram, specific heat capacity for that C is given as C into 200 degrees Celsius, that is the change in temperature, and we will be getting 2330 joules equal to 5000 G into degree centigrade into C. Divide both sides by 5000 G degree centigrade. So 2330 joules by 5000 gram degree centigrade is equal to C. By dividing this value, we will be getting the final answer C, that is specific heat of the metal. C is equal to 0.466 joules per G degree centigrade. Answer is that one. So the specific heat of the metal is 0.466 joule per G degree centigrade. So these are all the problems that we have solved for the topic of heat, energy and work done. Thanks to you.